Today I'm going to explain the definition of simple harmonic motion and also the derivation of distance and time of a particle executing simple harmonic motion. So now a particle is said to execute simple harmonic motion if it satisfies the following two conditions. The first condition is that the acceleration is always directed towards a fixed point. That means the particle is moving towards the center of force or the center of attraction. And number two is that and the acceleration is also proportional to the distance of the particle from that fixed point or from the center. So if I take O to be the center of attraction or the fixed point, and if P be the position of the particle at any time t, whose distance is x, that is OP is equal to x, then the acceleration in this case will be equal to, since it is proportional to the distance, and if x is the distance, so it will be equal to minus mu x in this case. That is, acceleration is called to minus mu x, where minus sign is because a particle is attracted towards a center. So in this case, the equation of motion for the particle executing simple harmonic motion will be minus mu x. Now, as I mentioned, that negative sign is because a particle is attracted towards a fixed point. So, or you can write it as v dv dx is equal to minus mu x, or v dv is equal to minus mu x dx. Now, if you integrate this one, what will you get? If you integrate, then you'll get v square by 2 is equal to minus mu x square by 2 plus c, a constant. Now, since a particle, we take O to be the center, P be the position at any time t, and A to be the initial position of the particle, which is at rest. That means at this A, position A, the particle is at rest, the initial position of the particle. And let us take the distance from A to O to be equal to small a. So now here it means that when the particle is at A, x is equal to A and V will become 0 since it is at rest. So therefore, putting that V is at A, you can write this one using the initial condition at A. V is equal to 0, x is equal to A. So this implies that this part will become 0. So you'll get 0 is equal to minus mu A square by 2 plus C, which means that C is equal to minus mu A square by 2. So you can substitute it here. Then you'll get V square by 2 is equal to minus mu x square by 2 plus, it will become plus here by transferring this one to that side. So it will become mu A square by 2. So half can be cancelled. Then you'll get V square is equal to mu into A square minus x square. So V square is equal to mu into A square minus x square. Now from here you will see that what will be V? It will be minus square root of mu into A square minus x square. Negative sign is because the particle is, the x decreases as x moves towards O. That means as t increases, x decreases. So therefore we are taking the negative velocity, that is minus square root of mu into A square minus x square. That is a negative square root of V square. So now here you'll get V is equal to, but what is V? V is equal to dx dt. So this implies that dx dt is equal to minus root mu into square root of A square minus x square. By method of separation of variable, you'll get this one. Dt will be equal to, or I can take this root mu this side also, doesn't matter. Root mu dt is equal to minus dx by square root of A square minus x square. Now let us see here. We know this is the relation of the velocity and distance. V square is equal to mu into A square minus x square. Now as a particle moves towards O and on reaching O, the x will become 0. X is equal to 0 at the center or the fixed point. Therefore in this case, what will be the velocity at the center of attraction or the mean position? It will be V square is equal to mu into, at O, x is equal to 0. So in that case, what will be the velocity? V will be equal to minus square root of mu into A square minus 0 square. So this gives you V is equal to minus root mu into A. Square root of A square will be A. So that means the velocity at the center of attraction will be equal to minus root mu into A. But since the velocity is not equal to 0 at this point and it is negative, so the particle will continue to move towards the left side of O. So it will continue to move towards the left side of O, And on reaching A prime, whose distance is equal to A, that is OA prime is equal to A, and on reaching this one, x becomes A. So what will be the velocity at this point now? At A prime, x is equal to A. So in that case, what will be the velocity at that point? It will be minus square root of mu into A square minus A square, because x is equal to A in this case at A prime. So you'll get here the velocity now become 0. That means the velocity at A prime will become 0. And since a particle is always directed or attracted by the force towards the center of attraction, so the particle will not stop here, but it will start moving back towards O, where the force at the center attracts the particle. So in this case, the particle will move now towards the right side of O, and then on reaching O, the particle will have the same velocity minus mu into A, and the particle will not stop here. So it will move to the right side of O, and it will continue in this way. So in this way, the particle execute a simple harmonic motion. It start from A, this is O, this is A prime. So it start from here, move towards the center of attraction, and since velocity at this point is not equal to 0, so it moves towards A prime, and on reaching A prime, velocity becomes 0, and since a particle is again attracted towards the center, so it will start moving in this one from A to A prime, back to A, and so on. So in this way, the motion is simple harmonic motion. So now in this case, let us find out what will be the distance and what will be the time taken for the particle to move from A to O. So we have here V is equal to minus square root of mu into square root of A square minus x square, or dx dt. I'll write straight away that one. Dx dt is equal to minus root mu into square root of A square minus x square. Or here you'll get dx by square root of A square minus x square is equal to root mu into dt. So here you see that if you integrate this one, you'll get what? Integral of minus dx by square root of A square minus x square will be equal to root mu integral dt. Now let us see what will be, we know that minus integral of dx by square root of A square minus x square is cos inverse of x by A. So you'll get here cos inverse of x by A is equal to root mu into t plus some constant, say d here. Now let us find out what will be the value of this constant d here. We know that at A, this one, at A, t is equal to 0, but x is equal to A. So using the initial condition, that is at A, t is equal to 0, x is equal to A. So this implies that d will become what? This one will become 0, and this d will become cos inverse of A by A. But what is cos inverse of 1? It is equal to cos inverse of 1, but cos inverse of 1 is equal to 0, implies that d is equal to 0. So therefore you get cos inverse of x by A is equal to root mu into t, or x by A is equal to cos root mu into t, or x is equal to A cos root mu into t. So this is the distance of the particle at any time t for a particle executing simple harmonic motion. Now let us find out what will be the time taken by the particle to move from A to O. So again we have this relation from here. For that one, from A to O, x is equal to 0 here, but x is equal to A here, and t is equal to 0 here, and at O let time be equal to t. Therefore integrating this one, it will be minus dx by square root of A square minus x square. Now here it will be from A to O, so it will be x is equal to A to 0, where x is equal to 0 at O, the center of attraction. So this is equal to what? Root mu integral 0 to t dt. So you'll get here cos inverse of x by A from A to 0 is equal to root mu into t, you'll get here. And on substituting this limit of integration, you'll get this one as cos inverse of 0 minus cos inverse of A by A is called root mu into T. And the cos inverse of 0 is equal to what? It is equal to pi. Or it is equal to pi by 2. Cos inverse of 0 is pi by 2. Now A cancel, cos inverse of 1 here you will get, but cos inverse of 1 is equal to 0. So it will be pi by 2 minus 0 is equal to root mu into T. And this implies that T is equal to pi by 2 root mu. That means the time taken by the particle to move from A, sorry, not this one, from A to O will be equal to pi by 2 root mu. So what will be the time taken to travel now by particle from A to A prime and then back to A? That means it will be 4 times, because from here to here it is pi by 2 root mu. Then from here to here it will travel with the same time, that is pi by 2 root mu, and then back to O it will be by pi by 2 root mu, and then back to this one it will be pi by 2 root mu. So the total time taken by the particle now to move from A to A will be given by, let us take it as T, which is equal to, it will be 4 times of small t. So it will be 4 pi by 2 root mu is equal to 2 pi by root mu. So this will be the time taken by the particle to move from A to back to A. And that time will be called as the time period. So the time period will for a particle executing simple harmonic motion will be given by T is equal to twice pi by root mu. Now let me define the definition of frequency. What is frequency? The frequency is the number of, and this one oscillation here, let me define the definition of oscillation. One complete oscillation is a distant time, or the time for one complete oscillation is a distance covered by the particle in that time t from A to A prime and then back to A. So now here that one will be one complete oscillation from A back to A. So the number of complete oscillation from A to A prime and back to A will be called as the frequency. So the frequency is defined in this way: the number of complete oscillation in 1 second. Given time is, specific time is given here in 1 second. So that means how many complete oscillation does the particle execute simple harmonic motion here in 1 second. Say if it is n, then in that case n will be equal to 1 by t, the time period. And we know that n is, what is t? It is called twice pi by root mu, implies that n is equal to 1 by twice pi by root mu. This implies that n is equal to root mu by twice pi. That means the inverse of t will give you the number or the frequency, that is the complete oscillation, the number of complete oscillation in 1 second. So I hope it is clear regarding this one particle executing simple harmonic motion. You go through it. In case if it is not clear, you please let me know. And then I'll send you the solved problems from that exercise 2.1 of Juneja, which are the application of this theory part of simple harmonic motion.